All right, this is section 2.4 or 2.4, more modeling with functions. We start by reminding ourselves, and these are linear functions, by the way. So we start by reminding ourselves what a linear function is. It is one that is of the form f of x equals mx plus b. Okay, m is the slope. Remember that the slope is the rate of change when you think about a word problem. Like, for example, if you're going at 25 miles per hour, that's your slope, the rate of change, because your position is changing at a rate of 25 miles every hour. And b is the initial value, which we also call the y-intercept, right? Remember also that this is really the same thing as y equals mx plus b. But when we're writing functions, then we should write f of x. We should not write y. Okay? All right, number one says, find the formula for a linear function f that models the data in the table exactly. Have we done a problem like this one? We have, except we said find the slope-intercept form of the line, right? Just different words, but the same thing. That means our job is to find the slope and the y-intercept. If we cannot find that, right, we have to find the slope, and the slope is there. I don't know if you guys remember, we did the little jumps from one to the next. And we can do that for both of these, but we really only need it for one. That means we've been told it is linear, so we don't have to check every slope. We can just check between any 2 points. We can just use the first 2 points. So we can find the slope right there. And then if you know what the y-intercept is, you're set to go. You just plug it in there. You plug your slope and y-intercept. If you don't know what the y-intercept is, don't forget you can write y equals m times x minus x1 plus y1, and then distribute and work to get to the slope-intercept form. Okay? Don't forget also, we do not want to leave the y. We want to change that to f of x at the end. Okay? Because it is a function, f. We want to use function notation. All right, let's go on to number 2. And again, I'll start you off, and we will finish these in class. This one, I'll start you off. I'll get you a little bit further on this one. It says, write a symbolic representation for a function f that models the situation, state the domain. In 1992, the number of injury cases recorded in private industry per 100 full-time workers was 8.3, and it decreased on average by 0.32 injuries every year until 2001. All right, so same thing. So we need to write f of x equals mx plus b. Right? Which means we need to find the slope and the y-interchange. So in word problems, you want to look at the slope as the rate of change. Okay, so something is changing at what rate? Okay, and then b is your initial value. Notice in this case it's 8.3. Right, that's your initial value. However, that's for 1992. If I go back up here, something we want to remember is for the y-intercept, x equals 0. That means in function notation, you're really just looking for f of 0. So down here, 8.3 should be f of 0, right? And the way we have it written right now, it's f of 1992. We can't have that. Somehow we have to represent 1992 as 0. We can do that just by saying x is the number of years since 1992. Notice that in 1992, the number of years since 1992 is 0. In 1993, the number of years since 1992 is 1, and so on. Okay? All right, so now you know kind of what you're looking for. All right, and finally, to state the domain, right, so your x values are going to go from 0, which represents 1992, to this other number, which will represent 2001. Okay, so you'll have to figure out what number do you use to represent 2001. Okay, I'm gonna let you finish that. Okay, your slope is written there, by the way. You have your b, which I already pointed out to you, and your slope or your rate of change. Yeah, all right. Let's go on to and we will do it in class, and we'll finish it in class. Okay, so if you do any part of it, we'll check it there. Let's go on to number 3. This is about piecewise defined functions. What is piecewise defined? Well, that means that on a particular interval of its domain, right? And its domain is wherever there's a graph, right? Whatever x values have a point somewhere on the graph. All right, so if you look at that part there, that's a line that's going up. And then if you look at this other part over here, from x equals 2 to x equals 4, that's a piece of a line going down. It's called a segment of a piece of a line. So its segment is part of a line that's slanting downward. This segment is part of a line that's slanting upward. And that's what piecewise defined is, that it's you'll have a different looking shape on different parts of its domain. Okay? All right, so those are graphed for us. Let us work from there to answer these questions. What is the domain of f? So remember, if you remember looking at graphs, we're answering x values, right? And we're scanning from left to right, and the domain includes anywhere, any x value where there's graph. So before -4, there's no graph. Starting at -4, there's graph. There's a break here, but all you need to know is there a point that has x value 2? Up here, that point is hollow. That means there's no point there. But if you look down here, there is a point at x equals 2. And then you continue. There's graph, 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 graph till there, till x equals 4. Okay? So the domain is from -4 to 4, including each of those, because there's little solid dots at the end. Okay? You do not need to break it off here because there is a point at x equals 2. That means there's a point at every x before 2, there's a point at every x after 2, and there's a point at x equals 2. So there's no break in the domain. F of -3, and we've seen this before, that means x equals -3. What is the value of y? And that refers to a point on the graph. So how do you find that? Well, you go to x equals -3, go to where the graph is at that point. It's down here. And then check to see the coordinates. That's -3, -4. So x equals -3, y equals -4. Notice you're just answering the y value that corresponds to x equals -3. F of 2, same thing, exactly the same thing. You go to where x equals 2, because that's what they're telling you, x equals 2. Go to where the point is on the graph. It's not up there, that's a hollow point. That means there's no point there. But it is down here. The y coordinate of that is -4. So f of 2 is -4. Notice that the first one refers to the point -3 comma -4, and the second one refers to the point 2 comma -4. All right. F of 4, same thing, right? Go to x equals 4. The graph is down here. Y is -8 on that point. Okay. Notice again that refers to the point 4 comma -8. There it is. Is f continuous, and how do we determine it? The way you determine it is if you scan from left to right. You can scan backwards, but let's keep it from left to right. That if you were to trace your graph of your function, that you don't have to jump to keep tracing it. That you can trace it all the way across its domain without picking up your pen or your pencil. If I try to do that, I trace, stop. And then I have to jump over here. I cannot, there is no points here in between them that are on the graph, so I have to jump, and then I keep tracing. And as soon as I jump, then I know it's not continuous. Okay, and there will be some that are, even though they're piecewise defined. Okay, let's go on to page 2. All right, and we look at number 4. And number 4, so number 3, we were given a graph of the piecewise defined function. Number 4, we're given the definition of the function. That means in symbolic form. We will have to graph it. Okay? All right. So, how do we graph it? Let's graph it first, and then we can find its domain. By the way, we can find its domain before. All these we can find before we graph it, and we'll do it after we graph it, but we'll graph it first. How do we graph? Well, you take a look at the shape that you're following. So for the first part of the graph, you're following the shape y equals x plus 3. Right? What shape is that? Well, it's a line. This is y equals mx plus b. So the slope is 1, the y-intercept is 3. So and where does that, on what part of the domain does that occur? From x equals -3 to x equals 1. So we're going to block off from -3 to 1. Yeah, and the way you can do that is, you see me using my fingers. You don't want to keep your fingers there because then you can't write with anything. What I do is I put little dotted lines. Okay, at x equals -3, I put a dotted line at x equals 1. Right, and then after that, so I'm going to have a certain shape from here to here. And then after that, my shape is going to change slightly to y equals 2x minus 1. That's a line with slope 2, y-intercept -1. from x equals 1 to x equals 3. So from x equals 1 to x equals 3, so I'm going to put another division over here. Okay, and I don't have to do that, but it really helps. Okay, so I got a division at x equals -3, x equals 1, and then x equals 3. All right, so how do I draw that in? So the first one, the line y equals x plus 3, has y-intercept 3 right there. Notice it's going to be part of the line, so I'm going to go ahead and fill it in. And then slope 1. And slope 1 takes me up 1, 1 to the right. But notice this says I cannot have a point there, right? It doesn't say less than or equal to. It says less than 1. So it doesn't apply at 1, but I need a point somehow. I'll just put a hollow dot. Okay? All right. And if I go the other way, slope 1 takes me this way, and then do I put a solid dot here or not? Well, it says yes, x equals -3, yes, solid dot. Okay, and I'm just going to fill in the rest of the line. Yeah, notice I could put dots here. The dots just say I'm including this point, I'm just highlighting that point. Yeah, okay, so there's that part right there. X plus 3 from -3 to 1, not including 1. How about this one, 2x minus 1 for x from 1 to 3. So 2x minus 1, the y-intercept is -1, but I can't put it there, right, because I'm only graphing from here to here, right? But I can tell where it goes, right? Slope 2 means I'm going to go up 2, 1 to the right. Is there a point there? Yes, at x equals 1, that's included. All right, up to 1 to the right, that's included, and up to 1 to the right, and that's included up to all the way up to, and that's where I stop, right? Notice that my line that goes through there actually keeps going, but I can only include in the graph that part right there. Okay? All right, so I'm going to break it off there, and we will continue with these on the next video, part 2.